Welcome to The Explainer. Today we're talking about something huge, something powerful, a force of nature you've definitely felt, but you've probably never actually seen. And it secretly shapes everything from our weather to how we travel. All right, let's kick things off with a travel mystery I'm sure some of you have noticed. Why is it that flying from, say, New York to London can be a whole hour faster than flying back? You're not just imagining it, I promise. There's a real, fascinating reason behind it. And the answer? Well, it has nothing to do with the plane itself, or even the pilot. It's all about a massive, invisible river of wind flowing thousands of feet above us. A current so powerful, the planes have a choice: fight against it or ride it like a superhighway. All right, let's dive into Section 1, Rivers in the Sky. So, what is this powerful force we're talking about? Well, it has a name. It's called the jet stream. So what are jet streams exactly? Well, just think of them as these narrow, super fast currents of air that are literally circling the entire globe. The best way to get your head around it? Just picture massive, invisible rivers flowing through the sky. And when I say massive, I'm not kidding. The scale here is just mind-blowing. We're talking about a current that can be over 1,500 nautical miles long. It can be 200 miles wide and stretch over 2 miles deep into the atmosphere. And the speed? We're looking at winds starting at nearly 70 miles per hour, but they often get way, way faster than that. These things are absolutely colossal. So, okay, that brings up a pretty big question, right? What on earth is powerful enough to create and maintain winds on that kind of scale? I mean, where does all that energy even come from? Well, that brings us to Section 2, the sun's uneven breath. And the engine behind all this wind? Turns out it's the same thing that powers pretty much everything else on our planet, the sun. It all boils down to one fundamental principle. The sun just doesn't heat the Earth evenly. Because our planet is a sphere, some parts get blasted with direct, concentrated heat, while other parts get a much weaker, more spread out dose of sunlight. So just think about it like this. Near the equator, you've got that direct sunlight essentially cooking the air, making it warm, making it expand and become less dense. But way up near the poles, that same sunlight is spread out super thin, so the air stays really cold and dense. And what you get is this massive planet-sized difference in temperature and pressure. And the jet stream? It forms right at the boundary line, where these two gigantic air masses, the warm and the cold, smash into each other. It's basically a high-altitude battleground, and the intensity of that clash is everything. You know, an aviation meteorology expert said it perfectly. The bigger the difference between the warm and the cold air, the faster that jet stream is going to flow. That temperature contrast, that's the fuel. That's what makes this invisible river rage. Okay, on to Section 3, Riding the Wind. And this brings us right back to that New York to London flight. So how exactly do pilots use these invisible highways? It's actually pretty simple. The major jet streams on our planet flow from west to east. So if you're flying east, like from New York to London, you get this incredible push from behind. That's a tailwind. It boosts your speed over the ground and cuts down your flight time. But on the way back, you're flying west, straight into that current. It's a headwind, and it slows you right down, making the trip longer. Simple as that. Now, what's really cool is that pilots don't just aim for anywhere in the jet stream. They're trying to find its core. Think of it like the fastest lane on the highway. This is the center of the current, where wind speeds are absolutely insane. We're talking 100, sometimes even 200 knots. That's over 230 miles per hour. Hitting that express lane saves a ton of time and fuel. Moving on to Section 4, Bumps in the Air. Because, you know, riding these incredibly powerful winds, it's not always smooth sailing. The very same forces that give us this helpful highway in the sky can also cause some of the scariest moments in flying, turbulence that seems to come out of nowhere. This stuff is called clear air turbulence, or CAT for short. And if you've ever been on a plane just cruising along on a perfectly clear, beautiful day and suddenly, bam, the plane starts shaking and dropping, yep, you've met CAT. It's that nasty turbulence that gives you zero warning. No clouds, nothing. So how can that even happen? How can the air get so bumpy out of the blue? Well, it all happens right on the edge of the jet stream. Just imagine this river of air blasting along at hundreds of miles an hour, right next to a block of air that's barely moving. That massive difference in speed is called wind shear, and it creates absolute chaos. It's like stirring a cup of coffee. You get all these violent swirls and eddies that can toss a 747 around like a toy. And here's a really interesting little detail for you. That turbulence, it's usually strongest on the colder side of the jet stream, the side closer to the pole. Why? Because that cold air is heavier and denser. So when that super fast jet stream slams into it, the disturbance it creates is just way more violent. Okay, let's look at the bigger picture in Section 5, our planet's weather engine. Because the jet stream's influence goes way, way beyond just being an aviation shortcut. Its biggest job, really, is being a fundamental part of our planet's global weather engine. This is why this stuff matters to every single one of us, whether you fly or not. The path of the jet stream is what steers huge weather systems across the globe. It literally dictates where major storms will go. It acts like a giant fence in the sky, keeping that frigid polar air separate from the warmer tropical air. So, long story short, the location and the strength of the jet stream directly impact the weather you're getting right outside your window every single day. And, it's not just one big river of wind up there. Our planet actually has several major jet streams. You've got the two really powerful polar jets circling near the poles. Then there are two subtropical jets a bit closer to the equator. And on top of that, you have other seasonal jets that kind of pop up at different times of the year. Each one has its own part to play in our global weather patterns. All right, let's wrap this up. What are the key takeaways here? First, jet streams are basically giant rivers of fast-moving wind high up in the atmosphere. Second, they're powered by the sun, heating our planet unevenly. They're the reason we get tailwinds and headwinds on flights. Their edges are a main cause of that scary clear air turbulence. And maybe most importantly, they are a vital part of what drives our planet's entire weather system. And that leaves us with a really big, critical question for the future. We've just learned that jet streams are fueled by that big temperature difference between the poles and the equator. So, as our planet's climate continues to change and that temperature gap starts to shrink, what's going to happen to these powerful rivers in the sky? How will they change? That's a question scientists are racing to figure out right now.